Okay, let's talk about functions. Here's the definition. A function is a set of ordered pairs where each x value, which we call the input, has exactly one corresponding y value, which we call the output. Okay, there's a lot of ways to look at this. So we're going to begin with an informal definition. Okay, so the informal definition of a function is like a machine that turns one thing, called the input, into another thing, called the output. And it never changes its pattern. You always get the same output for a specific input. So looking at this machine, it's like something comes in and this will come out something else. So X comes in and it comes out Y. If you can think of it as a machine. Now let's do some specific examples because you're probably going, what? Let's talk about a vending machine. I think everybody has at least seen a vending machine where you put some money in and you punch a button and then out comes whatever it is you're going to buy. So every input has only one output. For example, if you enter A1 and there's a Snickers right next to A1, you will get the Snickers bar every time. That's a function. If you enter A1 and you don't get a Snickers, that's malfunction. If there's a Snickers bar there, that's not okay. If you get A1 and you either get a Snickers or a Cheetos, that's not a function, okay? So we're going to call this function VM for vending machine. And one input would be, say, A1, and the output would be Snickers. So function notation would be my name of my function, vending machine of A1 Snickers. Let's try another one. Suppose I hit B13, and right next to it is the Cheetos. So that would mean that vending machine of B13 equals Cheetos. Okay, give you an idea. Let's try a different one. All right, how about a person's birthday? There is only one birthday per person. So let's call this function VD for birthday. Input is going to be Marge. And it's going to be M. And output is, my birthday is January 21st. So I'll do that. I'll do 121. Okay. So function notation would be birthday of Marge equals 1-21. Now, I cannot have any other output from that. I mean, there's a unique output. I was not born on any other day, so that makes this a function. Let's try one more. Let's try Bradley. We'll call it B. And that birthday would be May 19th, so we'll let that be 5/19. So the function would be birthday of Brad equals 5/19. Okay? Okay, so a function can also be a group of numerical values, okay, just a bunch of numbers in a table, a graph, which we'll talk about later on, an equation, which we'll see pretty soon, a verbal description, which is pretty much what we just talked about with the birthdays, or a combination of these. So let's see what we're talking about. Very often in math, a function turns one number into another number. So if you put one number in the function, it comes out a different number. So there's a function called the square root function. And this is what it looks like. If you take the square root of x, you will get certain numbers. So this is my function. And it can look like points. So if this one is, if I take the square root of 1, I get 1. If I take the square root of 4, I get 2. If I take the square root of 9, I get 3. If I take the square root of 16, I get 4. Okay, that's just one way to look at it with points. Here's the numerical, which is just a table. So if the input is 1, the square root of 1 is my output, 1. If you put in 2, the square root of 2 is 1.4, blah, 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 blah. It goes forever. That's an irrational number. If you put in 3, the square root of 3 is another irrational number that goes forever. But if you input the square root of 4, then the square root of 4 is a nice little 2, and so on and so on and so on and so on. So this is just right now, this function is only 1, 2, 3, 4, 5, 6, 7, 8, 9 members in this function. This one has 9 members. Okay, let's go back up to this one. This one had 1, 2, 3, 4 members. Very small function. They can be any size. They can be infinite as well. Here's a graph of the same function. Okay, this is, let's look at if my input, so input is going to be the x. If my input is, let's go to 9. Okay, if my input is 9, my output is the y, 3. So that would be, you could look at it as if you put in 9, you get a 3. Okay, that's the graph. All of these have, here's 4. This is the easy one. 4 goes to 2. This is infinite points here, because I could take the square root of 6.5 right here, or 6.3 or 6.2, and I'll get the square roots up here. So this one has infinite inputs. And by this going to the edge of the graph, that means that goes forever as well. And just, I think the first one is 0. You can't have a negative in this one. Okay, so let's look at now this is the equation, and this is what it looks like. This means the function of x equals the square root of x. So this is my definition. So if I want the function of f of 9, we call it f of 9, that means I want the square root of 9, which would be 3. This has infinite values. You can't even, you just, all by itself, it puts everything in there. If I want the function of 100, or sorry, f of 100 would be the square root of 100, which is 10. Okay, what if I put in f of negative 100? Can you take the square root of a negative number? You put no solution. No, sir, not there. Don't want. Okay, and finally, the same function we can do verbally, and that is just in words, the square root of a number x. Okay, so let's talk about the formulas and how we evaluate a function. All right, the directions are going to be evaluate the function at the given values. Okay, so my function itself is an equation, and it's basically saying 3 times my input and then subtract 2. Okay, so that's f of x. So if my x, this is my x, if my x is 3, my function is 3 times my x minus 2. So all I do is I take that 3 and I substitute it in where the x is. So it's going to be 3 times, what's my input? 3, and then subtract 2. So I would get 7. So that means that f of 3 equals 7. Let's find f of negative 1. So now I'm going to put negative 1 right there into the x. So 3 times negative 1 minus 2. Order of operations, 3 times negative 1 is negative 3. Then I subtract 2, so negative 5. So my answer would be f of negative 1 equals negative 5. And let's just do one more. F of 10, so I'm going to put 3 times 10 minus 2, which is 30 minus 2, or 28. So the answer to this one would be, I wanted to do it in black, f of 10 equals 28. Okay, and that's how you evaluate a function. Let's do a few more. Okay, this one's a little more complicated function. All right, it's got a fraction. We got to really follow our order of operations. Okay, so this is called h of x. The name of our function is h. Doesn't mean anything. Okay, we're just learning how to evaluate a function. So what does that mean? Plug it in. Plug in 2 wherever there's an x. So what I have here is I have 5 times my input over 3 times my input plus 6. That's what my function is doing. All right, so if my input is 2, I'm going to take 5 times my input over 3 times my input plus 6. Okay, then I need to simplify using order of operations, and I get 10 over 6 plus 6, which is 10 over 12, and always reduce our answers in simplest form by dividing both of those by 2. I would get 5 over 6. So final answer, h of 2 equals 5, 6. I'll just highlight that one. Okay, now let's do h of negative 3. So I have 5 times negative 3 over 3 times negative 3 plus 6. That gives me negative 15 over negative 9 plus 6 is negative 3. Final answer, positive 5. So that means h of negative 3 equals 5. And let's put in 0 into my function, which means I get 5 times 0 over 3 times, I like this one because I already know it's going to be 0 over 6. So h of 0 actually equals 0. Okay. And there's one more thing we need to be able to do besides evaluate the function. So evaluate the function is just plug it in, right? So this one is solve for x given a function. So this one's a little bit different. They're not giving me the input here. They're giving me the output. So I need to take my function 4x plus 3 and find out how to make it equal to the output. So take your function and set it equal to the output. Now just solve for x like you know. Okay, so what is the x value that comes out 11? That's the question. And I'm going to solve that by just minusing 3 from both sides, dividing by 4, and that means x equals 2. In other words, f of 2 will come out to be 11. You could say that either way. Okay. All right, let's try it again. Aha, it comes out to negative 1, do you see? Because that's my input, that's my output. So I put my function right where f of x equals, and then set it equal to negative 1. And then just use algebra to solve. 4x equals negative 5, divide by a messy 4. X equals negative 5/4, or f of negative 5/4 will come out to be negative 1. Okay, so this is different. This one, they give us the output and we have to find the input. Okay, we'll try one more of these and then we'll take a break. Actually, we'll try a couple more. Okay, so this is another equation, only it's a quadratic. So we're going to take our quadratic, x squared minus 3, where f of x is, and set it equal to 13. And now, since there's no b term here, I'm going to just add 3 to both sides. And now if I square root both sides, I get x equals plus or minus 4, x equals 4, x equals negative 4. Okay, so what does that mean? That means f of 4 will come out to 13, as will f of negative 4. Okay, let's try this one. So my same function is x squared minus 3 equal to negative 1. So if I add 3 to both sides, I'll get x squared equals 2. Then if I take the square root of x squared, I get x. If I take the square root, I have to have plus or minus the square root of 2. And that's as good as it gets. So x equals the square root of 2, x equals negative the square root of 2, or f of the square root of 2 comes out to negative 1, f of negative the square root of 2 comes out to negative 1. Okay. Problem solution, problem solution. Okay, these are also ways to talk about the solution. Okay, I do think there's just one more I wanted to do. Actually, we'll put this in the next video. So let's go ahead. No, let's keep going. Sorry about that. Let's solve for x where we have a trinomial. So again, they're giving me the function to come out to 15. So I put the x squared minus 4x plus 13 equal to 15 and then solve that equation. If you recall solving equations, the first thing we do is set equal to 0. So I will minus 15 from both sides, and I will get x squared minus 4x minus 2. And I can see that that is not going to be factored. It looks like the quadratic formula. A is 1, B is negative 4, C is negative 2. Opposite of B, so we're going to have a positive 4 plus or minus the square root of b squared, which is 16, minus 4ac all over 2 times a. Okay, so if you're not, I'm just doing the quadratic formula here. We talked about this. Okay, I need to simplify that. This is a minus times a minus, so that's going to be 8. So it's going to be 4 plus or minus the square root of 16 plus 8 is 24 all over 2. This is the square root of 4 times the square root of 6. So this will become 4 plus or minus 2 times the square root of 6 over 2. And if I split these up, it's easier to simplify. And then it becomes 2 plus or minus the square root of 6. And that's what x is. That's a lot of work, but you know, it's good to see that quadratic formula in play. So what that means is that f of 2 plus the square root of 6 will come out to be 15. And also f of 2 minus the square root of 6 will come out to be 15. Oh boy. There we go. Okay. I am going to pause the video here, and this will be continued.